finishing up the 3B notes in this section. The next, number 6, is evaluating. We have done this before. In fact, in 3A, we did a lot of this. We were given different geometry formulas, and we were putting in numbers, and we were just evaluating them to find the areas, the volumes, the perimeters, and all that sort of thing. Now, these are just random formulas that we're putting them in, and we just put in the values. So if y equals 3, that means the top of this fraction is 8 times 3 over, and z is equal to 6. And then we just plug this into our calculator, 8 times 3 over 6, and we should get 4. Now this next one is, you really got to be careful when typing this in your calculator. If I put in the values, it's going to be 16 minus 6 over 5. When we do this, I have to do the 16 minus 6 first. Sorry about that, I bumped the thing. And it's 10 over 5, which is equal to 2. If you have the TI-30, the kind of one, not the multi-view, you will have to make sure you put the 16 minus 6 in parentheses. If you have the TI-30 multi-view, you can just type a calculator and type it in as exactly like this, and it will work. But if you don't have that one, you need to do 16 minus 6 in parentheses divided by 5. Please be careful on that. This next one here, translate each phrase to an algebraic expression. Use n as your variable. When we're doing these questions, make sure you use the letter that they are telling you to use. It will change. It's very similar to those percent problems that we're doing where it said use a as your variable, use y as your variable. And if you forgot to do that, it marked you wrong. It was very frustrating, but you do understand the concept, and you get another chance at the question and you move on. So just please be careful. All right, 4 more than a number. Well, anything that's more than a number is we're going to be adding. Now again, we're letting n be our variable, so it's just n, and then we're going to add 4 to it. I'm sorry, my keyboard keeps popping up on me. N plus 4. All right, tripling a number. That means I'm really just multiplying it by 3. So that would be 3 times n. If I'm quadrupling it, it would be 4 times n. If I'm just doubling something, I'm multiplying by 2. There's all kinds of versions of this. 3 more than twice a number. So now we're getting into multiple step things here. More than means addition. So I know I'm going to be adding 2 things here. Now if it's 3 more than that, so let's say you make $12 an hour and I make $3 more than that, I'd be doing my 12 plus 3, wouldn't I? So I'd be adding 3. Twice a number, again, that's just doubling something, 2n plus 3. Now what's great about addition is this is the same as 3 plus 2n, so either answer will work. Unfortunately, in the next one, we're not going to be so lucky. This is 3 less than 5 times a number. This is a very awkward one. All the other ones, we've been just simply translating straight in from English to algebra. If you're making $15 an hour, and I make $2 less than you, so I make $2 less than your $15 an hour. When you do this in your brain, you immediately think 15 minus 2, and I make $13 an hour. Unfortunately, here it's 3 less than 5 times a number. It's in the abstract, so we don't see this as clearly. But when we see this less than right here, if you notice, what comes second comes first in math. So if it's 5 times a number, that has to come first, and we got to do minus 2. I'm sorry, minus 3. It's 3 less than a number. 2 less than was the one I made up. But again, this less than, it gets very tricky. This is where the algebra and the English are backwards from each other. This last translation one is the sum of. Well, the sum of means I'm going to add up two things. So I know it's going to be addition. Well, one of the things is twice a number. Well, that's 2n plus 6 times another number. So another number means I got to use a different letter. So that's going to be plus 6 times y. Now, in the question that you will be doing, it will tell you both letters. Here I only said use n as a variable. For this case, since it didn't say it, I just let y equal. Usually they'll say let one number be x, let the other number be y. And so you would go from there. Use greater or less than to write a true sentence. Okay? So if I'm using this, which is bigger, a positive 1.5 or a negative 2.7? Well, positive numbers are always bigger than negative numbers. I know 2.7 is technically a bigger number, but would I rather have $1.50 or would I rather owe $2.70? I think everybody wants to have a positive. Now part B here is again a review of Unit 1. In Unit 1 what we did was we made them to be the same denominator. Now 8 and 11, the common denominator is 88, so really over here I have to multiply top and bottom. To get better at this. Oh, why is that popping up? Sorry about that. You can tell I'm learning as we go. I'm multiplying top and bottom by 11 here, and then I'm multiplying top and bottom by 8 here. So really I have 55 over 88, and then we have 56 over 88. When the denominators are the same, I just look to see which numerator is bigger. 56 is bigger than 55, so this one is less than. Finding the absolute value. Absolute value, I'll give a quick definition of this, is the distance a number is from 0. So if I have a number line, I'm going to draw a quick little number line here. Here's 0. And if I look at negative 2 is 2 spaces away from 0. So the absolute value of negative 2 is 2 spaces. Now, as the same thing, if I do positive 2, again, positive 2 is 2 spaces away. So the absolute value of 2 is also 2 positive 2. So that's kind of weird. Now here, when we're looking at it, negative 5 is all the way out here, but it is 5 spaces away from 0, so that is why it is positive 5. When we talk about distances, we always talk about positive numbers. Now the absolute value of positive 5, now that's all the way over here, but again, it is 5 spaces away from 0. So the absolute value of negative 5 and positive 5 are both 5. They're both 5 spaces away. Now they like to throw this in occasionally. How far away is 0 from 0? Well, it's 0 spaces away because it is the same. They're just trying to be a little silly there. Now scientific notation. Some of these numbers, if you type this on your calculator, it will immediately change it to scientific notation on its own. And you can experiment with this. Now, if the number is not big enough, the calculator will leave it in a numerical form. It won't translate it to scientific notation. But if you remember from the very beginning at the notes at the top, scientific notation always is a number between 1 and 10. And then it is times 10 raised to some power. Okay? So now, where can I move the decimal? Now, if the decimal is not written, remember the decimal always starts right there, to the right of the number here, if it is not written. You can look at the next question, you can see the decimal is there, so clearly it would not start to the right of the 4, because there is a decimal in there. So since the decimal, we need to move it between 1 and 10. Now, if I put it between the 8 and the 7, let's say I put it right there, 98.7 is clearly not between 1 and 10, So that would be the wrong spot. What I do need to do is I need to put it right there between the 9 and the 8. So my base number is 9.87. Sorry, you can see me struggling again. Now, if I moved it over to the 9.87 here, how many spaces did I move it? Well, if the decimal starts here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I moved it over 11 spaces. So the answer is going to be 9.87 times 10 to the 11th. I'm sorry, I got a little off. Okay. Now, big numbers like this it's a big positive number, so it will always have a positive exponent. This 0.000 is a very, very tiny number, so I'm going to have a negative exponent on it's going to be 10 raised to some negative number. But again, to get the number between 1 and 10, I have to move the decimal between the 3 and the 4, because 3.4 is between 1 and 10. And then it's going to be 3.4 times 10. Now, how many spaces do I need to move it over? Starting here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spaces. So it is 3.4 times 10 to the negative 13. Now, I believe both of these examples will work on your calculator if you just type them in. And then you can just prove to yourself that it does work. Sometimes on the tests and the quizzes and the homework, they like to give numbers that won't change on the calculator, so you have to know how to do it by hand. Okay? Now you can go into your calculators and change the mode over and over again, but sometimes people forget to change it back, and then all their questions are wrong in the other ones, and everybody gets frustrated. So, but if you can do that, that's great. If not, this is the best way to do it. The next one here, we can actually type this in on our calculator again, but actually the calculator will give you the right setup, but it will be wrong if you type it into the computer to try to check your answer. So please be careful on this. Now, it is 10 to the negative 8. So now if it's a negative exponent, that means it's a super tiny number. Which way do I move the decimal to make it smaller? Well, I'm going to move it to the left to make it smaller. But I have to move it 8 spaces. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and then I write my decimal right there. Now the 0 in front is optional. You could do it or not do it. It does not matter. The computer won't care. But all these waves, empty waves, I need to put a 0. So 1, 2, 3, 4, 5, 6, 7. So I add 7 zeros. So this answer is 0.1234567533328. Please try to type this in on your calculator and you'll see it will just truncate it somewhere. It will just round to one of these spots. I don't remember exactly where it'll stop, but it may stop around here. And then if you forget the 2 and the 8, the computer will mark it wrong because it didn't say to round to anything. They want you to type this giant number in. Okie dokes. All right, I think that's the last question, and it is. Please forgive me. For some reason, my hand was hitting the keyboard. It was popping up. I will hopefully get better with this. Now, this is the longest video I've done. It's a 14-minute one. But again, this is the end of 3B.